Okay, I got the case all cleaned up now, and I got the oil pump out here. Got the gears all cleaned up and the shafts. Got everything pretty well getting ready to go together here on the oil pump side. So we gotta get all this stuff put together here yet. I went ahead and checked the pump, make sure it fit the case, which it did. We need to put the left seal in also over here. And I need to take the fittings out of the oil pump over here because these oil fittings are very restrictive and they need to be opened up, get some flow through this pump. Otherwise you have very low flow. We don't like low flow. Yeah, that's about the right size right there. Except that won't work. So we gotta go ahead and modify a couple things here. So go ahead and put the camera over here so you can see me do the pump. We'll use the milling machine to drill it out, but I got to take the fittings out in the vise over there. So these are just half-inch fittings here, but they're in there. Oh, usually they're in there pretty damn tight. And that was easy. Only went in a couple threads there. So you can see how restrictive this is. Where's that light at? I don't know if you can see in the hole there. It's only like an oval-shaped hole, because it has a separate fitting the way they drilled it in there. So you can see it's very, very restrictive. This one's not very good high flow either, but compared to this, it's night and day. Look at this, like triple the flow, and this is bad. So you can see how badly restricted these fittings are. So yeah, these things aren't very tight at all. The last one I had to use a damn breaker bar to take it out just about. So instead of taking this fitting out and doing it, I'm going to drill it, open this up in here, and then I'll open this one up here. That way they'll be 100% even all the way through. But you can see how restrictive that hole is there too. So, got to play with that a little bit. Alright, so I'm going to go ahead and put my left main seal in here. So it takes two special tools. It takes a hammer and a pipe coupler that I modified to a flat surface, and I beat the hell out of it from this side. And I beat the ceiling with that. Too cheap to buy a Jim's tool. Now my other stuff works just fine. So here's the seal right here. So you make sure it's a decent seal. Make sure it's clean, so you use something clean to clean it with. And you drop it on the floor just to make sure it's still clean. You want to make sure the bearing, the seal surface here is not too chewed up. This one has a little bit wear lines in there, but that's it, no pitting or anything. So this is a real tall one, like for fuel injected bikes, so not sure why he has that in here, but that's what he brought over, so that's what we're going to use for now. If he has to pull this out, he'll have to put another seal in it. I'll teach him to bring over the wrong parts if it's not right. I want to get this bearing sealed up because I don't want to have dirt and stuff getting in here. So if it costs him a seal, too bad. Okay, I always put the seal on the race first. Slide it on in there. You kind of compress on one side and loosens up on the other. I put the seal in backwards so it works correctly, or backwards for Harley. That's normal for most people. I'm trying to keep the oil in the motor, not out of the motor. Harley has the other way of doing it for some reason. Sure, they got a good theory on that one. Okay, I just put the coupler on the end of the seal and I just beat it in. Work your way around in a circle. Oop. When you hear the steel, you know you're all the way in. It's best not to hit it in the crank. Okay, once you get that all the way in there, and shove it all the way in, wipe off any residue. It's in there. See, now dirt can't get in there very easily. It can still come in the end of the shaft here, but it'd take a lot to get in there now. When the bearing's wide open, anything can go in there. Once those roller bearings don't roll anymore, the lower end don't last very long. Okay, always make sure it turns after you do everything. Yep, still turns, so that's a good sign. Okay, so that's it for that. So now I'll go ahead and go open these up here in the mill. So we're going to take our camera and go for a little walk here. Go over to the milling machine over here. Let's see, I think you got a good view of it right here, hopefully. There you go. Got two ways of doing this. You can use drills or reamers. Drills want to dig in, reamers don't. Reamer will leave a better round hole also. The drills cut quicker and easier, and they'll cut out big areas quick. So first thing I want to do is figure out what size hole this is here on the top, so I can use it for centering purposes. So right off the bat, it's bigger than the number 1 drill. So let's go check out a 1/4 inch drill. Not quite a 1/4 inch. Next one down, works good. And the other drills, sorry at what? See, that was what size? That was 234. Yeah, they got all kinds of one right in that area. Appears to be 246. Yep, no it isn't. It's 246 on this side, but not on the drill side that matters. Next size down. 242. The other one I want to get is the one that goes inside that hole that's in there, which is pretty small. That's nice. See how the hole goes in an angle? So I can't use that as a centering device. Not that big. It's actually a 1/4 inch hole in there almost. Yep. Same size as this one, 242. Okay, we'll go ahead and drill the long fitting first. So what I do is I put in a drill chuck. So we're using the drill bit to center up your hole so you're on center. So I don't know if you can see any of that over there. Reposition the camera a little bit. Okay, so you know the drill goes right in there, so we know that this is straight up and down. We're trying to get this here straight up and down. We want to drill through at an angle, you know, like that. We want it to be straight. Okay. Okay, I usually go one size over 1/4 inch. So that would be the 17/64, which is a 265 thousandths drill. You can also use a reamer if you want. I'm going to use a drill. Now this might try to grab and just screw right in there, so you gotta be careful. It might auger in. So you just gotta be careful. Okay, went all the way through. So even though we didn't go very much, look at the difference in hole size between the two. So get it where you can see it in the camera there. One side is actually quite a bit. My race bike I'd go even more, but street bike you want to make sure the fittings don't break off. Okay, close enough. Put the cutting bit in there. If you push too hard at the bottom down here, you'll drill straight through, so don't go that far. It's best to not drill straight through. Trash can over here and get to it. Okay. Now this one, see, now we can't hold it with that. We're going to have to just eyeball it square. I'm pretty good at doing that. Check it from 4 different angles to make sure you're square, because your drill chucks never chuck up evenly. Close enough. Okay, we take the same 1/4 inch. We're going to go straight through. Now this one here, the hole is off center and at an angle. So when you go down, it's going to start wanting to grab in real heavy with the drill. Now the drill press is not a problem because I can control it. If you're doing it by hand drill, it's going to really want to take off on you, so you have to be careful. It's best to use a drill press, otherwise it'll drill sideways on you. So we can go ahead and knock this all out one side straight through. With a reamer I'd have to step drill it. With a drill bit I'll go straight in. Too much metal coming out quite a bit. Okay, I think I hit bottom. Yep. Okay, now you can see a difference in fit and flow. So it's night and day. See, the light might be hurting the view there, I'm not sure. So anyway, it's a huge difference in overall hole size through these things. So you can just imagine how much more flow you're going to have over the one there, this one over here, compared to the one that's all plugged up. So that's why we do this. Wrong thing. I would imagine we're probably getting a 500% in flow increase, which means your oil pump will put out more pressure, more volume, and less heat, less foaming. It's not going to cavitate. They got these connected to a high flow pump as well as a standard pump. And there ain't enough flow here to do a standard pump. So you definitely got to open this stuff up. It doesn't hurt to check all the fittings up the whole system too. Check the ones on the oil tank. Make sure they're all opened up. There. Do this one again. With the drill chuck, I can control that. See, it just spins on here and tries to chew it up. If you have a hand drill, you would have broke the drill off and wrap the chuck around your hand, doing all kinds of damage. So, okay, after you do it, I take my deburring tool and I deburr the hole. So that gives you a nice radius inlet, which makes it flow even more. So I don't know if you can see the difference between the two there, but the radius inlet makes a difference. I'm not sure which way the oil is flowing on these, so I just do both surfaces. Oop. Damn it. Trying to show you what I'm doing and do it. Makes it hard. This is a carbide deburring tool. This is a Vargas brand. There it is. Made in Israel. They got other brands too. So these things work very, very well. They're quick disconnect for changing out your bits. So lots of different brands of these. Very, very handy. Okay, so that's all opened up now. So I'll go install these back in the pump. And we should be good to go on this. Ready to put the pump in the bike.